Saxon's Trig, lesson 89, is about the ellipse the second time we talk about it. So we already know that the standard form for the equation is x squared over a number squared plus ry squared over another number squared, and the problem must equal 1. And if, yes, ellipse squish circle. Okay, for a split second I was doing hyperbolas, which had the minus sign. Okay, so yes, your ellipses have the plus signs, and they remind you that if the larger number is on the x-axis, then that's the major axis, and then the minor one would be the vertical, the y-axis, or that could be flip-flop. This could be the longer as the major, and this one be the shorter as the minor. And no matter which way, we know that the ellipse has 2 focus points in it with the string connecting with your pencil or pen. And as you rotate around, you're getting the ellipse. So this is the shortest distance that it can go when you stretch it, and these are the wider distances that you can go. Now, so I've not given you anything new. So in example 1, write the standard form of the equation of the ellipse with vertices at. So here's what's new. They're giving me the vertices are at positive and negative 5, 0, and positive and negative 4, 0. Just a second, that can't be right. Is this one the 0 positive? No, hang on. Write the standard form of the equation of the ellipse, vertices at positive and negative 5, 0. Oh, foci. I knew something was weird there because both can't have them in the same x spot. Foci at positive and negative 4, 0. That definitely computes. Okay, so write the standard equations. This is all they give us. We're going to draw a picture to help us get organized here so that you can see and understand what is happening. So this is going to be the major one since the foci point, I didn't say that before, the foci point is always on the major one. So it's 1, 2, 3, 4, 5, out, 1, 2, 3, 4, 5 the other direction. Technically, I'm only going to work on this side though. And that's the vertice point. The foci point is here, so that's the foci point. So what we're going to do is we're going to draw from the foci point out to some spot on the y-axis. And I don't know how high this is because it gave me no information about it. So we'll call it y because it's on the y line. And we know that that is a 4. This has definitely created a right triangle. And this hypotenuse length will match with the length of the vertice. So this is a 5. Now that we know that, we can Pythagorean theorem to find this line. So 25 minus 16 is 9. The square root of 9 for the side then makes the fact that our y will be 3. And now I'm going to label that there. So in my standard equation, I know I have x squared over plus y squared over. It's going to equal 1. On my x-axis, the vertice was 5, so we know that's going to be 25. This one is a 3 squared to a 9. And now I have the problem in, I'm just checking to see, write the standard form of the equation of the ellipse with, and that's all it asks for. So standard equation, there it is. Example 2, write the standard form of the equation of the ellipse whose, and again, they're giving me vertice is at 0, positive, and negative 6, and foci point, I'm guessing, yes, at 0, positive, and negative 5. They're not always 1 away. These examples happen to have it that way. So 0, 1, 2, 3, 4, 5, foci point, 6, vertice point. And then I know I'm going from the foci point somewhere down to the other spot. We'll call it x because we don't know it. That one's 5. And then the hypotenuse will be 6. Pythagorean theorem. So once you get this pattern, if you can handle just using these numbers without the drawing, that's fine too. So 36 minus 25, 11. So then x squared is 11. So x is the square root of 11 because it didn't go nicely. All right, but it wants the equation of, so x squared over, And when I do the square root of 11 squared, I get 11 plus y squared over, and that one was 6. 6 squares to 36, and the whole thing has to equal 1. There is another example, 3. This says a horizontal ellipse, which means the major axis has to be horizontal. Major axis length of 10. If the length is 10, then each part has to be 5 because the major one was 10. The other side is going to cut that in half. Minor axis of 4, which means this half is going to be 2. The bottom half is going to be 2. And it has its center at origin. Okay, so now I know that that dot is 0, 0. Find the coordinate of the foci. So on the major one, somewhere will be a dot. And obviously, if this is the 5, the furthest point out, it will be less than 5. So that's going to connect to that y-axis there of 2. Write the equation in standard form and graph it. All right, so this is a rough sketch, but not an actual sketch. So let's work on this is our unknown x part to the foci point. The full length is 5. That makes the hypotenuse 5. So 25 minus 4, so squared, is 21. So the x squared is the square root of 21. So x is the square root of 21 there. Yep. And my full equation then would be x squared over this full line was 5, so that's going to be 25 plus y squared over this half was 4, 2 squares to 4 equals 1. So there's the standard equation that it asked for, right? Yes, write the equation in standard form. I'm looking for where they did that. Oh, right there at the very bottom. And then once the the point for the focus. So the focus point will be, and it's moving over, so we are going to both the positive and the negative version of the square root of 21, and then nothing up or down, so 0 for those focus points. And it wants the actual graph. Seeing if I could actually fix that one or not, and I'm not sure that I can. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 outer on the major, and then 2 on the minors. There is the actual squished ellipse, squished circle, therefore making it the ellipse. And if I wanted to label the foci point, I could figure out what the square root of 21 was and put an actual dot and label it foci point, but it didn't ask me to do that, so there's what they wanted.